Alright, we're looking at factorising a to the power of 4 plus 4b to the power of 4 by adding and subtracting. Alright, so you can see, if it says adding and subtracting, and that's kind of looks like a middle term. So I'm going to add it there, in between those two terms, and then subtract it here. So over here you can see I've got, hopefully, if I square root both the first term and that last term, it's 2b squared, and square that. If I double the product, I do get 4a squared b squared, so that's all good. And then I've got minus 4a squared b squared. Now that's just the difference of two squares. So I'll have a squared plus 2b squared at the front of each of those, a squared plus 2b squared. And then I'm going to add and subtract. What am I going to add and subtract? The square root of that, so 2ab is the square root. So difference of two squares. Alright, so yeah, so we could leave it like that, that's fine. Just says factorise, hence prove. Alright, so if you look at that, I need it to really be in this form here. Well, it looks like the A is 545, because that's already to the power of 4. But the B part, I need to first pull out a 4. So that's a 4, lots of 4. I'll take one away, so 444. And I want it to the power of 4. So 4 lots of, so here if I want it to the power of 4, I'm going to have divide it through by 4. So 4 something to the power of 4. So 4, I've got 1 left over is 14, so 3 is 12, 2 left over is 6. So 4 to the 136 to the power of 4. So you can see my B is going to be 4 to the 136. So I'm just setting it up so it looks the same, and then I can put that in. So if I do that, I'm just going to rub out my working here so I have room to write it. So 136. Actually, I might not do it. Just imagine that maybe I'll start it. Alright, so we've got 545 squared. We've got 2 lots of b squared. So if I double 136, I've got 272, I think. Here I've got 2 lots of 545 and 4 to the 136. That's in my first bracket. My second bracket, I've got 545 squared plus 2 times b to the, again, squared, so 272 minus 2 lots of 545 and 4 to the 136. Alright, so we're proving this is not prime. Well, if it's going to be prime, one of those factors is going to be 1 and one is going to be itself. Now clearly none of those is 1. That's not equal to 1, that's not equal to 1. Therefore, this is a composite number. Okay, we've been able to factorise it. And therefore, it cannot be prime.